There are certain rules that allow us to manipulate exponential expressions. And we're going to deduce these first for positive integer powers, and then we're going to define powers that are not positive integers such that these continue to apply. So for any real number x and positive integers m and n, if we multiply x to the m power times x to the n power, we just add the exponents. And to see why, let's look at just how these are defined. So x to the m power, that's m copies of the number x multiplied together. And then x to the n power, well, that's just n copies of the number x multiplied together. And so if we put those together, well, that's m plus n copies. Right, we wrote m copies, and then we wrote n copies. The total number of copies is m plus n. And so that is x to the power m plus n. So the reason that multiplying powers adds the exponents is just because that's how we define the powers. We have a similar rule for division, that when we're restricting ourselves to positive integer exponents is a little bit tricky to state, because we have to state it in slightly different ways, depending on whether the larger power is in the numerator or in the denominator. If we have x to the m over x to the n with m the greater number, well, that's going to be m copies of the number x over n copies of the number x. And when we have fractions, of course, we can cancel like factors in the numerator and the denominator. So now, because there are more x's in the numerator, I'm going to split that up. So I'll have n copies of my number x, and then some more copies to get the total up to m. How many more copies do I need? Well, that'll be m minus n copies. And then in my denominator, I still have n copies. And so I have common factors between my numerator and my denominator, which I can cancel out. And all that remains is my m minus n copies. In other words, all that remains is x to the power m minus n. What if the power in the denominator is greater? Well, I start out the same way. Again, I have m copies in the numerator and n copies in the denominator. But now I'm going to split up the denominator. So I'll have first m copies, and then I need enough additional copies of x to bring the total up to n. So this must be n minus m copies. And the numerator stays the same with m copies. And so again, I'm going to cancel common factors between my numerator and denominator. And in my numerator, I'm just left with 1. In my denominator, all I'm left with is my n minus m copies of x. In other words, x to the power n minus m.